So now we have a mint function and we have a deposit function. So we can deposit collateral, we can mint DSC, but additionally, we can get account information. We can calculate someone's health factor. We can calculate the USD value of these different tokens. So at this point, I'm like, oof, I have no idea if what I'm doing makes any sort of sense. I want to make sure I write some tests here. So this is where we could go ahead and create a new folder, unit tests. And if you wanted to, you could skip writing the scripts and just kind of deploy in your unit tests and then do some integration tests. But I'm just going to have my unit tests also be my integration tests for this one. So let's go ahead. Let's write a script. Deploy dsc.s.sol. You already know the drill for this. SPDX, license, we can even zoom in a little bit. Identifier MIT, contract, deploy DSC is script. Import script from forge std script.sol like that. Pragma, Solidity 0.8.18 looks good. In here, we're going to have our function run external. We've done this 100 times. External. And this is going to return a couple of things. It's going to both return the decentralized stablecoin and the DSC engine. And it's going to return something else, but I'm not going to put it in quite yet. So to do that, we're going to have to import decentralized stablecoin from /src/ decentralized stablecoin.sol. We're going to close and reopen my VS Code. It's being really weird right now. There we go. All fixed. So the two of these, what are we going to do? Well, we're going to do a vm.start broadcast like this, vm.stop broadcast like this. Oh, and we need the DSC engine. Import DSC engine from /src/ DSC engine.sol. And in here, we're going to deploy both of these. So we'll say decentralized stablecoin DSC equals new decentralized stablecoin. Does our decentralized stablecoin have any parameters? It does not. We're also going to deploy our DSCE, our DSC engine equals new DSC engine. This takes a whole bunch of stuff, right? This is going to take, go to the constructor, token addresses, price feed addresses. If we toggle the word wrap, addresses, price feed addresses, and the DSC address. So we have the DSC address. Boom. It's going to be this one. Where do we get the price feed addresses? And you guessed it. We're going to make a helper config. So what does this DSC engine need? Constructor, an array of token addresses, an array of price feeds, and then the DSC address. So where are we going to get those addresses from? You guessed it, a helper config. So new file, helper config.s.sol, spdx, license, identifier MIT, Pragma, Solidity 0.8.18, contract, helper, config is script, import script from forge std/script.sol. For now, let's do this on the Sepolia chain. So we'll do struct network config. What do we need in here? We're going to need WETH and wrapped Bitcoin, those price feed addresses and those DSC addresses. Address, WETH, USD, price feed, address, wrapped Bitcoin, USD, price feed. Again, WETH is the ERC20 version of Ethereum. I've got an example WETH token contract on Sepolia. And if you look at it right in here, we go to write contract. It's got this function deposit where you deposit ETH and it'll return to you an ERC20 version of ETH to your MetaMask called WETH. Then whenever you're done with it, you just withdraw your ETH and burn your WETH. Wrapped Bitcoin is something similar, but with Bitcoin. The difference is since Bitcoin doesn't originate on the ETH blockchain, there is some risk in bridging it over, but I'm not going to go into that. That's something for you to look up. So we're also going to need the address of the WETH token itself. We're going to need the address of the wrapped Bitcoin itself. And we're going to need a UN256 deploy deployer key, kind of like what we did in one of our previous lessons. We're going to have network config, public, active, network config, and then we're going to have constructor, like here. We're going to have a function, get Sepolia, eth config, public view returns, network config, memory, this, and then we're going to return network config. We're going to have WETH USD price feed be, let's go to docs.chain.link. Let's go to Sepolia. Where's ETH BTC? ETH USD right here. Copy that. Paste. Comma. We're going to need wrap Bitcoin USD price feed on Sepolia. Bitcoin USD right here. Grab that. We're going to need the WETH contract address, which I have here. This is one that I deployed. WETH here. We're going to need wrapped Bitcoin. And if you're looking for all of these and you want to just copy them out of the GitHub repo associated with this, you can go to SRC. You can go to script, upper config, and they're all in here if you want to just copy paste, by the way. But also wrapped Bitcoin, which I guess is this address. Thought I had a different one. Well, whatever. We're going to use this one. And if it doesn't work, that's fine. We're going to use this one. And of course, deployer key, vm.env unit, private key, like this. Okay. And then we're going to do function get or create anvil eth config, public returns, network config, memory. And we're going to do a little bit of mock deployments here. But we're going to say if active network config dot weth USD price feed does not equal to the 0 address, then we've already set it. Turn active network eth config. We're going to do some broadcasting. So we're going to need a couple of mocks in here. We're going to need some mock price feeds and some mock ERC20 tokens. So we're going to need a mock v3 aggregator, which we're going to go to test, new folder, mocks, and I'm going to copy paste a mock from this repo. If you want to copy paste as well, go for it. Test mocks, mock v3 aggregator. Copy this. New file, mock v3 aggregator.sol. Cool. Import that. Imports mock v3 aggregator from /test/mocks/mock v3 aggregator.sol. So we have that. We're also going to need some mock ERC20s. We can get those actually directly from OpenZeppelin. So if we do import ERC20 mock from @OpenZeppelin/contracts/mocks/ERC20 mock.sol. And if we command click into this, or you open this up, you can see there's a whole bunch of stuff in here. Like we can mint as much as we want, burn as much as we want, do transfers and stuff. We can do pretty much whatever we want. And that's why it's a mock token. Good for testing with. So down here, vm.start broadcast. We're going to create a mock v3 aggregator, ETH USD price feed equals new mock v3 aggregator. And what does this take for the constructor? It takes decimals and an initial answer. So we're going to scroll up here. We're going to say uint 8 public constant decimals equals 8. And we'll say int 256 public constant ETH USD price equals 2000 E8. And then we're going to do the same thing, but instead of ETH, it's going to be BTC, and we'll make this 1000 E8. ETH USD, scroll down. All right, new mock. What does it take? Control click. uint 8, decimals initial answer, control minus to go back. Decimals, and then the initial answer. Those, okay. Oh, and let's do vm.stop broadcast. Now we're going to do ERC20 mock weth mock equals new ERC20 mock. What does this one take? Name, symbol, initial account, initial balance. Okay. Say weth, message.sender, 1000 E8. We probably want to do more than, we probably don't want to have these floating numbers in here, but yeah, it's just a mock. It's not a big deal, I guess. Now we're going to copy paste all of this for BTC. We're going to say BTC. It's going to be the wrapped BTC, wrapped BTC, wrapped BTC, like that. Stop the broadcast, and then return network config. Weth USD price feed is going to be address. Oh, thanks. GitHub Copilot. Thanks, GitHub Copilot. Thanks, GitHub Copilot. Thanks, GitHub Copilot. And this is actually going to be the default Anvil key, which if you want, you can just go back to here again and copy paste it out of here. Or, you know what? You just run Anvil, scroll up, boom, private key right here. Cancel that. We'll say uint 256 public, or excuse me, int 256 public default Anvil key equals, paste that in, and we'll say, we'll just use the default Anvil key if you're working with Anvil. Okay, nice. So now we have get or create Anvil, get Sepolia. Let's update our constructor. So we'll say if block.chain ID equals 111.55.111, then active network config equals get Sepolia ETH config, else active network config equals get or create ETH Anvil config. Nice. So we've got a little bit of a helper config here, a little semicolon down here. This looks pretty good. What's wrong here? Sorry, this is a uint 256. Okay, cool. So now that we have a helper config, we can go finally back to our deploy DSC. Let's import that in here. Import helper config from helper config. Right at the top, we'll say helper config equals new helper config. And out of this config, we're going to get all of this weth, Bitcoin, weth, Bitcoin, deploy key, etc. So I'm going to say address weth USD price feed. Oh, I can even just hit tab and it looks like it has most of it. Yep. Weth USD, wrap Bitcoin, weth, wrap Bitcoin, deploy key equals config.active network config. Cool. That looks good to me. I'm going to toggle word wrap so that it wraps around. Okay, cool. We have all of those. Now our DSC engine takes an array of token addresses, an array of price feeds. So we can say, so right at the top, let's make those arrays. We'll say address, array, public, token addresses, address, array, public, price, feed, addresses. And we'll say token addresses equals weth and wrapped BTC. Price feed addresses equals weth USD price feed address, wrap Bitcoin USD price feed. Okay, cool. I think that's everything, right? Yeah. So now we could go back to this line now. DSC engine, new DSC engine, and it takes the token addresses, price feed addresses, and DSC. Okay, cool. And then finally, something we haven't really talked about too much, but this decentralized stablecoin, like I said, it's ownable, but it needs to be owned by the engine. So this ownable actually has a transfer ownership function, and we're going to call that to transfer ownership to the engine. So we'll go back to our deploy here. Oh, sorry, this isn't DSC. It'll be address DSC. So then we're going to call DSC.transfer ownership to the address DSC engine. Now only the engine, only the engine can do anything with it. And then we're going to return all these. Return DSC and engine. Nice. Oh, and the deployer key is going to go here.